Hello everybody. So, section 2 of unit 2 is going to be starting with equations, and so this will be a lot of algebra review, which is going to be kind of necessary for algebra 2. So linear, we're going to focus on linear for now. What our linear equations are, of course, they are lines. Okay. When points on a graph lie along a straight line, it's called a linear relation, such as this. These relations can be written as equations. For example, the equation of this graph is written as x plus y equals 8. This is not the only way to write the equation. Of course, it can be rearranged different ways. And this form that it happens to be in is called standard form. So, standard form is where you have a times x plus b times y is equal to c, with some conditions for a, b, and c. Okay, so I would highlight this part because, at least for me, I know this is the part that I tend to forget about, where a and b and c are integers, and a is greater than or equal to 1, so it's positive, and the GCF of a, b, and c is 1. Okay, we'll see what that means in a minute. GCF, I think I said it wrong. Greatest common factor. Yeah, I think I said the letters the wrong way. Anyway, alright, let's take a look at what we've got going on. So, we've got some examples of practicing getting this in standard form. Starting with this right here. So, the issue going on right here is that the coefficient a is not greater than or equal to 1. So it also, that's saying it can't be negative. Okay, so the first issue here is that it is negative. Alright, so we got to change this. How do we get rid of this negative? Easiest way is to just simply divide everything by -1, and that'll make the sign of everything change. So when you divide this by -1, we have to divide every single term by -1, including the other side of the equal sign, and that'll get rid of our negative. And then we'll leave us with 5, and that's okay, we can have 5. So, this will make it become positive 5x, and then this will become minus 6y, and then equals positive 12. I don't know why I did that. Alright, so anyway, there again, and then the GCF is greatest common factor. In other words, can A, B, and C, these three numbers, 5 and -6 and 12, can they all be divided by a common number? Yes or no? No, in this case they are already all reduced. Okay, you could divide 6 and 12 by 2, but you have to include the 5 in there, and there's no common factors that we can divide by. So the dividing by the -1 is just satisfying this condition right here. Okay, this is all good for this problem, but this part was not. All right, we'll do a few of these together. Y equals 2x minus 9. First of all, this is in y equals mx plus b form, in case you recognize that, which is different from standard form. So, standard form has x and y on the same side of the equal sign, so let's go ahead and move that first. I'll just leave y over here and move the 2x. So I would have to minus it because it's a positive 2x. So minus 2x to both sides. And then since x is in front, negative 2x will be out front, and then plus y. Y has no symbol, therefore it's positive. And then what's left over here is minus 9. And then now that I'm in the x, y, and then constant form, now I'm going to check these conditions. Is a greater than or equal to 1? Nope. It's negative, so we're going to have to do the same thing again. You can do this pretty quickly in one step. If you want to do it in one step and just say change all the signs, and then you're pretty good with doing that in one whack. Go ahead and do that. Alright, so now we're good with that. Now, do we have a GCF? Well, we got a 1 here, so very unlikely, as long as something has a coefficient of 1, that they can all be reduced. So, that is your answer. So these are completely simplified, alright? they're not, the originals are not wrong, but as far as the rules of standard form and completely simplified standard form, that's why we're changing these up. Alright, what's wrong with number 3? Quite obviously, 24 should be on the other side of the equal sign, right? So any constants have to be on the other side, so let's go ahead and do that. Remember, whatever you do to one side, you have to do it to the other side. Alright, last check is GCF. Do I have any common factors that 9, 6, and 24 all can reduce by? So that's the goal, is just getting this a completely reduced linear equation. And the answer is yes, they all do. They divide by 3. So divide every single item by 3. Divided by 3 is 8. Okay, leaving you with that. And so everything looks good now. So that is completely simplified. Okay, again, it's the same equation as this. It's not wrong. These are not wrong. Like, you can still put them in Desmos calculator and get the exact same graph. But as far as what the rules of standard form are, how they would show the answer, you know, on like a multiple choice question, that's what they would want, and it's a skill that's going to tie us into something else later as far as graphing goes. Alright, so we've got a few other ones going on here. Yes, we've got these fractions here. Let's go ahead and maybe get started on the fractions one and see if... So the issue here is the coefficient of x is not greater than 1, like it says. It is less than 1. So we have to eliminate... Oh, why did I go down that far? So we have to eliminate these fractions, okay? To easily eliminate fractions, the denominator is the item that we do not want to keep around. So in order to get rid of these two denominators, I want to multiply by a number, a multiple in this case. So a bigger number than 4 and 3. That 4 and 3 will eliminate them, okay? That number would be what? 4 and 3 both go into 12, right? Yeah. So let's start with that. Let's say I'm like, okay, I multiply this by 12, and this by 12, and this by 12. You're allowed to do this. You can, every single term can be multiplied by the same number, okay, or divided by the same number. So I know if I have 12 over 4, actually, probably would have helped if I just put it on top. 12 over 4, that's going to reduce to 1, and then the 12 is going to reduce to a 3. So I really have 3 times 3 on top, giving me 9. And the 12 on top, again, I should have done that in the first place, 12 over 3. I'm going to reduce that 3 to a 1 and reduce the 12 to a 4. So that's 4 times 1. So that was a minus sign. Minus 4y equals, and then 12. Oh, I forgot the x. 9x minus 4y equals 12. Alright, so now my coefficient is greater than 1. Just ask ourselves, can we divide 9, 4, and 12 all by the same number? No. We can divide 9 and 12 by the same number, and 4 and 12 by the same number, but not all 3. So that is the answer. Okay? Alright, go ahead and pause the video and try number 4 and number 6, and then press play when you're ready to see the results. Okay, go ahead and take a look at the solutions. 6, need more time. Alright, slope-intercept form, which we kind of already mentioned. Linear equations are often written in slope-intercept. So slope is m, and the intercept is b, and that's referring to y-intercept. So that is y equals mx plus b. So what makes this one different is that y is by itself, or instead of y, we could have f of x. Where m is the slope, and b is the y-intercept. And we'll get more into intercepts here soon. Let's start with slope. So slope is the rate of change, or rise over run, I'm sure as you remember. There are 4 types of slopes that we're going to review. We have a uphill slope, also known as positive. And that is where, here's your coordinate plane. And your line is going from a lower left hand to an upper right hand position, making it positive. I teach this in geometry, and like if you have the skier and the skier is starting on the left, in every situation the skier starts on the left, and if he's going upward up the hill, then he's going up a positive slope. And then negative. So if he's starting on the left-hand side, and if it's a negative slope, he'll be going downhill. So we actually start uphill. Oh, I don't know what was up that. Ignore that. I wonder if it'll delete. Yeah. Cool. Okay, then we also have a slope of 0. And slope of undefined. Oh, yeah, now we're getting into the sticky stuff. So one of them was vertical, one of them was horizontal. Do you remember which is which? Vertical, horizontal. Well, there's a special letter in horizontal that is also in 0, the Z. So this is your horizontal line. Has a slope of 0. Help if I could spell that right. And this, of course, would be vertical. Any vertical line has a slope of undefined. All right. Okay, moving on. All right, now we're going to practice some slope-intercept form and a little bit of graphing, just a little bit to get us started. First, we're going to do slope-intercept form and then graph the line. All right, starting with slope-intercept form. So there are no other conditions that we have to worry about like we did with standard form. So really with number 7, it's all good to go and ready to graph. So nothing needs to change with that. We are just ready to graph it, okay? And to graph, remember the first thing you do is plot. B, in this case, a positive 7, will be on my y-axis, so I'll go up 7. 1, 2, 3, 4, 5, 6, 7. And then the second thing you do is apply the slope. In this case, 2/5. So, 2/5. That means I can go up and I can go right. But, issue with this graph is I am running out of room. Okay? So, what you could always do is do the opposite. The opposite of up and right would be down and left. Okay? So, up, right would give me positive slope, but so would down and left. Okay? It would still connect to these other 2 dots. So, I'm going to go down 2 and left 5. 1, 2, 1, 2, 3, 4, 5. I think I lost count. 1, 2, 3, 4, 5. Out right there. So, it's my slope of down 2 over 5. And then, of course, I can take, let's see if I can get this to work. I've done this before. And I can take a line. And then I'll, of course, draw arrows onto the end of it to show that it is continuous and that it keeps going. Alright. There you are. So there's a little refresher on the graphing. So you will have to rearrange number 9 into y equals mx plus b, number 10 and number 8 looks okay. So why don't you go ahead and practice those. 3, 8, 9, and 10, pause the video, and then when you're ready to see, press play. Okay, here we go. So number 8, slope was -1 over 1. When your slopes are negative, your directions have to be different. So you could go down to the right, which is a negative and then a positive direction, or up and then left, which is a positive and a negative direction. As long as you see your dots are lining up and going downhill, making your negative slope, then that's just a quick way to test your line to make sure you're on the right track. And then of course you can take this. Well, I started initially, I wanted to say this, by plotting +2. So this was my first dot, and then I just made these other -1 slope dots F along with that, and then connect them and make my line. And then number 9, had to rearrange it. I moved X to the other side and then divided everything by 3, giving me this is my equation. Slope is -1 over 3. So I had to go, I started at -5 for my Y-intercept right here, so this was my first dot, and then I went ahead and made 2 dots, one going up and left, up 1, left 3, and down 1, left 3 to get, or right 3, and to get my 3 dots. It's a little bit safer to get 3 dots than just 2 dots, just in case you mess up one of them. And so your line should look like that, which is a negative slope line, which is correct based on that. So these things really should just be automatic, you know, pretty simple things that you can do and maneuver to be able to be successful in this class. But also we are going to be using the calculator a lot as well. But as far as generically being able to check your own answers, and we also have to check the calculator, make sure that the calculator answer makes sense. So if we got the basics down of, you know, identifying parts of the equations and how that relates to the graphs, then that just makes everything so much easier. Then, alright, on this one, I went ahead and everything was on one side. I know y has to be by itself, so I did this way. You didn't have to do it this way. You could have moved the 4x and the 1 over, and that would have been just fine. Moved y over, and then I had a -y, so I just divided everything by -1 and ended up with this. So this is the correct equation. Slope is -4 over 1. Remember, if there's no denominator, the denominator is 1. So I started here at my y-intercept of 1, and then I went up, left, and then down and right to get 3 points. So that was up 4 over 1, down 4 over 1. Connecting these will give me a line looking like this. One other thing to notice, keep in mind that the closer the number is to 1 or greater, the steeper the line gets. Let's see how this one is 1/3, so it's not close to an integer, so the flatter it gets. Okay, so the line will be steeper when it's a whole number or bigger than 1, and then it'll be a little bit flatter when it's less than 1. So that's that. Alright, let's go ahead and add in a vertical and horizontal equations. Okay, so these up and down lines, these are actually really, really simple equations. If you think about the points on this graph, it's intersecting at -3, 0. It's intersecting at -3, +3. So what do all of these points have in common on this line? They have this value, your x value, in common. Okay, you can always do that. Make yourself some test points if you're ever not sure. I'm like, oh, I know it's like a number, like x equals or y equals, but I don't remember which it is. And you make these test points and see that all the x's are the same. So this is x equals -3. That's the equation of this line. All of the equations that are vertical will start with x equals. So notice how it's like, okay, the y-axis is there's my label, but really all of these have the same x value. I know, math, why do they do that to me? Anyway, so then we have horizontal. Horizontals will be, of course, the opposite. So all the points on this line will be y equals Then you just look for whatever number it's going through. It's going through 1. So this one is y equals 1. Okay? And you can also test these in Desmos if needed. Let's move on to parallel perpendicular. Again, this stuff is reviewed from geometry, so I'm going to go pretty quickly through it. The slopes of parallel lines are equal. Parallel lines have equal slopes, and the slopes of perpendicular lines are opposite reciprocals. Okay, like opposite reciprocals would be like 1/2 and then -2/1. So opposite meaning I change the sign from positive to negative, and then I flip it because that's what the reciprocal is. Okay. All right. Determine whether the pair of lines are parallel, perpendicular, or neither. I'm just gonna do these simply in Desmos. I'm not really worry too much about the graphing, this graphing skills. We kind of already did that. Let's just go ahead and do these in Desmos. So we'll start with number 13. And then if needed, we'll just go through the algebra and see if we need to determine more. So go ahead and pull up Desmos graphing calculator, or you could use the yellow calculator as well. But problem with the yellow calculator is you can't type in the equation exactly how it is if it doesn't have y by itself. So you can, on the yellow calculator, push y equals, which is up here, and then type in the two equations, but you have to get y by itself first in order to do that on those. So I'm going to do Desmos, and most of you will want to use Desmos because it just saves you a lot of work. So I'm going to start by typing in my first one, 10x plus 5y equals 5. So exactly how they give me the equation, I can type it in Desmos. I don't have to rearrange this stuff and get y by itself at all. Kind of nice. All right, and then on the next line, -x equals 2y plus 16. Okay, and it, of course, shows different colors. You can change the colors here by clicking or taking it away, I guess is what it does. There's a way to change the colors, but anyway. All right, what we got going on? So let's see. It said parallel. Definitely not parallel. Different slopes. Perpendicular. I would say not. That does not definitely not look perpendicular. And I would just safely say we got neither. Again, we're not going to do a ton of these in Algebra 2 because this is really geometry. So, but we are going to be dealing a lot with equations and graphing. So, kind of doing these refresher things will help us learn the new stuff and be able to be better at it. Okay, does that make sense to you guys? Hopefully. Alright, why don't you guys try 14, 15, 16, see what you get, and press pause, and then when you're ready, press play and see the results. Alright, so here are your results. 14 was parallel, 15 was parallel, and 16 was perpendicular. I'll go ahead and show 14 and 16 on the graph. So 14 was these two, the red and blue. As you can see, they appear parallel. What you could do if you're not sure is zoom all the way out and see if you see any kind of change in their slopes to see if they're going to intersect. Look for an intersection point anywhere. You're not going to see one. And again, you can also mathematically arrange the formulas or the variables around so you get y equals mx plus b and see what the slope is, which would be m in front of the variable x. But we're good with this. So now I'm going to show you number, what was the last one? So x equals y equals. This is what they look like, and clearly a vertical line, horizontal line, they are perpendicular to each other. So hopefully that was not too much trouble for you. Alright, a few more things going along with this is just to review these vocab terms. The point where the graph intersects the x-axis is called the X-Intercept, which would be this one right here. That's my X-Intercept. And then this is the Y-Intercept. Y-intercept. Yes, we will deal with those a lot. We will do a lot of graphing. We're going to do most of our graphing in a later unit, but we still need it to get going. Identify the x and y intercept of the graph shown at the right. So in this case, my x-intercept is -3, 0, or just -3 is okay. 1, 2, 3, 4. So that's 0, so I don't go left or right, but I do go up 4. So y-intercept is 4, okay? The x-intercept is also referred to, now this is where we're going with, this is super important stuff. These vocab words, the x-intercept is also known as a root, or a 0, or a solution to an equation. We're going to do a lot with this, so I would highlight this. This is important, important stuff. This stuff right here. Yeah, don't want to forget that. All these terms mean the same thing. If it says find the roots, you're finding the x-intercept. If it says find the zeros, you're finding the x-intercepts. If it says to find the solutions, you're finding the x-intercepts. All four of these words mean this, you're doing the same thing in algebra, okay? So you will see a lot of these on the SOL test. So just know that they all mean the same thing, where the graph will cross the x-axis. Okay, we can do it algebraically. It's not really a lot of fun, I'm not going to lie. We don't really do it a lot this way. So we'll do one just to do it, but it's not going to be our primary way of doing this. To find the x-intercepts, you will set the y equal to 0 and solve for x. And to find the y-intercept, you will make the x equal to 0. So you just make the opposite variable 0. Okay? And then we can graph it. Find the x and y-intercepts of the equation. So starting out, alright, we'll make y 0. If we make y 0, we'll start with 0 equals, so I'm substituting 0 in here for this y. And then writing out the rest of it. You can really just do these graphing, and that's what I'm getting at. Oh. Well, it would help if now what I want to do is, of course, get x by itself. So minus 5. And then divide by -2. So x, simplify that. The negatives can go away, and it's just 5 over 2. So my x-intercept, and that is the x-intercept, is 5 divided by 2, or 5 over 2, comma 0. So, which makes sense. X came out to be this value, and y was originally 0, came out to be this value. So it just creates my coordinate. Alright, let's just change color because we can. Alright, so we're finding, so that was the x-intercept. Now we're going to find the y-intercept, which means the opposite variable has to be a 0. So we leave the y. The other variable becomes 0. This is 0 plus 5, which is just simply 5. So y is 5, making your coordinate 0, 0, 0, 0, 5. And that's your y-intercept. Ding, ding, ding. All right. So, you could find these, and again, you can just find these by graphing. Oh my goodness. Again, we're not as concerned with the graphing. I am more concerned that you know how to use Desmos and you can easily use it. So, y equals 5x minus 1. So, definitely, please, 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 every time that I'm using Desmos on here, do it with me, okay? Okay, y equals 5x minus 1, and it actually highlights them for you pretty good. Now, the one challenge will be when, for the most part, it will. So see on this one, it's showing me clearly the y-intercept is 0, -1. And if I click on this, so that was clicking on this dot. So you could easily do that. Click on these dots, 0, -1, and then point to 0. Now, I'm going to write those down, 0, -1, and then point to 0. Now just keep in mind, how do I get this into a fraction? Just in case they do have it as a fraction, as a choice, and you're like, I don't know which one it is. Let's see, does Desmos do this? Change it to a fraction? No, it does not. Yes, and that's right, yeah. There is no function to change decimals to fractions on Desmos that I am currently aware of, like math, like on this, where you do the decimal and then math, enter, enter. So 0.2, math, enter, enter. On the regular calculator, you can easily change your decimal into a fraction, giving you 1/5. Okay, so just keep that in mind. That's just you are supposed to have both calculators on the SOL test, and usually I allow you to use both calculators, online calculator and a handheld calculator. But just keep that in mind that this one, the Desmos one, from what I know, and if it changes, I will tell you. There's no function that changes decimals to fractions. So, yeah. Okay. All right. I am just going to let you try any of the practice on this. I wouldn't go too crazy worried about this, but go ahead and do a few of these, and I'll have the answers for you. When you're ready, press play to see the answers. All right, here we go. Last bit. So number 2. Here are your answers. Go ahead and pause the video whenever you need a chance, or whenever you need to, if I'm going too fast. Alright, if you need any assistance with these, just feel free to message me or let me know in class. Alright, I will see you in the next video for section 3.